So 3-5 is page what? 187? Is that what we said? Okay. So use the fact that the heights in the U.S. males normally distributed 692.5. Calculate each. Show the shaded normal distribution. Calculator command. Okay, so calculator command you don't have to really worry about. So problem number one. So basically, you're looking at, if this is 69, we're looking at this kind of shaded region. So between 66 and 68. So that's basically what you would show. And then if you jump on to Desmos, you can easily do this. And make sure you feel comfortable with Desmos on this. So I just type in normal dist, but you can also find normal distribution under the keypad, and I bet you at least one person in here knows where to find it. So if you go down, you find normal distribution, then someone's getting a Starbucks gift card. And so we have 69, 2.5. What you got for me? Is it a fancy one? All right. Gotcha. Thanks. Pass that over to Nate's desk, would you? All right. So if you hit the little plus, it shows you the normal distribution based on this scenario. And so if I wanted to find the amount of area or the percent region between 66 and 68, my lower bound, my minimum is 66. My top one is 68. So it's that little tiny area, so that accounts for about 23.0% if you rounded it, okay, or if you put 22.96 or 95, something like that. So that's basically how you do it. And then calculate the amount of U.S. males that are under that. So number two, if you have your normal distribution, woo, look at that, fancy. And we wanted less than 71. So look at this artwork that's taking place. So that's what you can do. And then Desmos does it so much nicer and neater for you. Nope, we don't need that. Hit the wrong button. So if I wanted to change this less than 71.5, so change your upper bound to 71.5. And then when you go down to your lower bound, if you delete that out and you're like, where's the infinity? We'll just click back out of it and it'll go to the infinity. So this is 84.1% of the area under the curve is less than 71.5 inches tall. That also goes into the probability that you randomly selected a male that they are less than 71.5 inches tall. You have an 84.1% chance of selecting that person from your random selection. And then number three, calculate people that are taller than, so normal curve, 69's here. And then we want greater than 67.5, so this is 67.5. So that's basically, that's all you'd have to show. Notice I'm not grayscaling it. So 67.5 is our lower bound. Change your upper bound, make it back to infinity, so delete it, and then just come and click off of it. And so this gets us to 72.6% of the area. So again, if I were to randomly select a male from the population, if I picked a male that was 67.5 inches or taller, we have a 72.6% chance of selecting it. And then it says calculate the U.S. male height that is at the 99th percentile. Okay, so this I kind of showed you yesterday how to make this work. Okay, so you're going to keep your normal distribution as is. You can click this off. So this is how you do it. You put a period. Okay, my curve went away. Don't worry, it's okay. Okay, and then you under functions, you go and you find under distributions, inverse CDF. So 99th percentile is 99%. 99% as a decimal is 0.99. So this would mean that if somebody was at the 99th percentile as far as height goes, as far as an adult male, they would be 74.82 inches tall. Okay, so it's way far to the right. So it's important that you realize that. Realize as soon as you put the period at the end of your normal distribution goes away. It's okay. It'll do the math for you. It's important to make sure you keep that period in there, and that should work out nicely for you. All right, hypertension. Hypertension. Assume that the diastolic blood pressures are normally distributed with a mean of 84 and standard deviation of 12. So I would imagine at some point, sometime in your life, you went and saw your doctor and they put that fantastic blood pressure cuff on your arm, and then they put the stethoscope right there at the base of your, or the bend of your elbow. They're listening for a thump thump, and they're reading the gauge. And so this is all information you could get pretty easily. So let's create our normal distribution based on this one. So they said 84 is the mean, and then 12 is this. So if I had the plus, this is our information. So they said less than 120 is normal. We need to look at diastolic, right? So less than 80 is diastolic. Between 80 and 89 is pre-hypertension. And then between 90 and 99, that's stage 1 hypertension. Stage 2 hypertension is above 100. Friends, does anyone know what hypertension does to your heart? Anybody know? Well, your heart is basically a big muscle mechanism. And if you have hypertension, your heart gets really big. Doesn't mean you're a caring, loving individual. What it also does is it makes your left lung smaller because your heart gets bigger in the region that's at. So it makes your left lung smaller unless your body is flip-flopped, which is basically about 1 in 100 people have their organs flip-flopped. You might have your organs flip-flopped. You might not even know it. The time they find that out is when they do a CT or CAT scan or MRI of your section. Or if you're the unfortunate person where it's like, oh, I need to get a portion of my liver resected, and all of a sudden you wake up and you have a cut on your right side and then a cut on your left side, that's because your liver's on the opposite side of your body, okay? True story, you really do. It's about 1 in 100, 1 in 120 people, their organs are flip-flopped in their body. And again, there's really no, yeah, so your liver, rather than be on your right side, it's on your left side. Your spleen, rather than being behind your left lungs, behind your right lung. Rather than having 2 lobes on your left lung and 3 on your right, it flip-flops. Rather than your heart sitting somewhat to the left of your section, it sits to the right.
That'd be a great advantage.
Could be.
So someone goes for a liver shot first, a lot.
They miss. And then they rupture your spleen. So, yeah. All right. So find the percent of the population that each category is based on diastolic. So we have diastolic listed. Okay. People who are normal, we want less than 80. So I'm going to change this to my infinity, negative infinity. If I plug in 80 here. So basically 36.9% of the population has a normal diastolic blood pressure. Okay, pre-hypertension is between 80 and 90. So change your lower to 80, change your upper to 89. So you have about 29% of your population that has pre-hypertension. And then people with hypertension is between 90 and 99. So change your lower to 90, your top to 99. Basically, you're looking at 20.3% of the population is stage 1. And then people who have above 100, change your top to infinity, change your bottom to 99. So you have about 10.6% of your population that has stage 2 hypertension. Friends, if you want to avoid hypertension, if you don't have hypertension genetically given to you because mom and dad both were predisposed to having it, things that you can do to keep away from it. Watch your weight, watch what you eat, get plenty of cardio, exercise. Cardio exercise is not channel surfing. Okay, if you are a TV watcher or a binge watcher, get yourself some sort of a cardio machine, get an elliptical or something, put it in front, and watch the shows. I often like to watch cops, and sometimes they act like the cops, and sometimes they act like the robbers, and it's kind of fun. Kid you not, true story. All right. Then number 6 says give a Z-score for a person with a diastolic blood pressure of 95. Show your calculation. Okay, so we want the Z-score. That means it's on the x-axis. Okay, so that's where we're going to have to use our next portion. So, so if you had a blood pressure, so I'm going to go dot. And my thing goes away, go back to functions, go back to inverse CDF. 95% is the same thing as 0.95, so plug in 0.95. And so basically somebody who has a blood pressure of 9, or let's see.
They have a pressure of 95.
They have a diastolic of 95. That means that, oh wait, if they fall in the 95th percentile, that means that they'd have a diastolic of 103.7. That's on the x-axis. So you're kind of using this to work backwards. So we're not finding, we know the area is 95%, so we're trying to find where that would fall on the x-axis. And then a person is considered to have blood pressure that is too low when their diastolic reading is below 60. At what Z-score is this? So if I change 60 to 60%, nope, that's not it. What is the Z-score of this? 60. Oh, so what we could do, actually, let me go back. I made a mistake. I'm sorry. All right, Z-score is observed minus the mean over the standard deviation. So I'm going back to number 6 because I made an error. I misspoke. I'm sorry. So I'm going to find a Z-score. I have 95 minus, what was the average? 84 was the standard deviation. Huh? 12. So that's going to give me 11 over 12. So 11 divided by 12 on Desmos. 11 divided by 12. So was that the answer I gave you guys originally? No. Okay. Okay. So that's if they have a have that. If I wanted to find the Z-score of the 60, I'm going to go 60 minus 84. 60 minus 84 divided by 12. So the Z-score of that is, they are -2 standard deviations below. That's their Z-score. And what percent of the population would have a blood pressure that is too low? So if you're 2 standard deviations below the mean, you can go back up here. Oops, undo. Let's clear this out. Go back to this. I want lower than 60, so clear that out. Go 60 and below. So you have about 2.3% of the population that has blood pressure that is too low. Okay? There's often top-notch athletes, usually the ones that are swimmers or runners, actually have too low of blood pressure because they exercise so hard, their heart is in such good shape, and their resting heart rate, the blood pressure is down.
On a diet. Yeah.
No, not necessarily. Sometimes with those people, they might have to, they might have them take a little higher iron count to keep the hemoglobin up in their system. So, I learned all this by having a medical class. All right, 3-6 notes. What page am I on? 79. So we've already seen quite a bit of this. So this is in the past 2 times we've used calculator command to find percentages. So we're working backwards. We've already done this. So if you have 35% of your observations, that means we're going to do the inverse CDF after the normal distribution. So if you were to look down here at number 15, So, again, what I'm looking for in this situation is I'm looking for where on the x-axis am I going to find, when I use inverse CDF, it means I'm putting the percent of area. 100% of the area is underneath the curve, so I'm figuring out the percent. So on this one, it says IQ is normally distributed with mean, 100 standard deviation 15. Who's in the 66th percentile? That means 66%. 66% is 0.66. So I can get rid of this. I don't need these anymore. So we're going to go 100, comma 15. Okay, here's my normal distribution based on that. Okay, you got to put the period. Don't forget the period. And then under functions, find inverse CDF. So you got inverse CDF. 66 percentile is 66%, which again goes to 0.66. So people that are in the 66th percentile means that that means, excuse me, I'm going with heart rates again, and I shouldn't have been there. That means their IQ, if they're in the 66th percentile, it means they have an IQ of 106.2. So they are above they are above it. You could easily find the z-score from that by going 106.2 minus 100 divided by 15. You'd find the z-score, but they're not asking for that. So, lo and behold, look, you got the same answer they got. Again, this is if you're using the graphing calculator, which we are not. We're using decimals. So we can ignore this because, again, we're not doing this. The one thing to remember is when I'm doing inverse CDF, you're talking about the area to the left. So if you wanted the area to the right, you'd go 100 minus your percent that it gave you, and it would give you to the right. And that's as far as I need to go. So tomorrow, that's when the sun will come out according to Annie.
Wait, that's me. Number 2.
There you are. We wrote this problem just for you. It's your glucose levels.
I've been looking for Dave all day.
He's number 2. If Gabriel is at the 29th percentile for glucose levels, what is his glucose level?
It's not looking good for me, is it?
You just have low blood sugar.
Oh, is that good or bad?
It depends. Are you fasting? Usually your fasting blood sugar at your age, that might be fine.
Okay.
If you're diabetic, that's bad. If you are not diabetic, that's something that shouldn't concern you because things will act nicely for you.
All right.
As you get older, it might move up. So 3-6 we'll do today. Tomorrow, during our sub day, I'm gonna go over this entire review. So I'll make a video kind of fun for you. You know, that stir up sarcasm in there. So just make sure you know how to log on to My Cherry Creek, go to Schoology, find the lesson, go with that. Easy? No, it's not. Dang it. It's not that fun, my freshman. I can't make it work. This doesn't work anymore. It's broken. No, it isn't. What? Yeah, just keep it quiet. All right.